Now that we've looked at the basics of ions and the basics of bonding, let's get down to actually the ionic bonding itself. An ionic bond is formed when we transfer electrons from a metal to a nonmetal. The sum of the charges in the new compound must also be zero, just like the two original elements. And so our classic example that I gave you before, which was sodium and chlorine, which form a +1 and a -1 respectively, are going to combine together to form sodium chloride. Notice they have a +1 here and a -1 there. So +1 and -1 do equal 0. So our compound is neutral. That's what tells us if that would be stable or not. If I tried to write Na2Cl and say that I was going to have 2 pluses and 1 minus, that would give my whole compound a +1 charge, and so that would not be stable. So this is the only way that this ionic compound can actually go together. If I have a +2 ion, and a -1 ion, and I put those two things together, then I am going to have to do some manipulation to the coefficients, the subscripts, because I have a +2 here and I only have a -1 for my fluoride. Okay, so since that's the case, I'm going to have 2 of those fluorides in order to make this neutral. And so what happens is I have the 2 fluorine molecules, which are F minus, and for every 1 +2 calcium. And so the formula for that is going to tell me that I have 1 calcium and 2 fluoride atoms, okay, or ions. So that's what it takes for me to maintain that balance. And so how I figure that, go backwards and make sure if I see this written, if it's correct, is that I know that I'm going to make a +2 out of my calcium because it's in group 2A. I know fluorine is found in 7A, which is a -1. So in order for +2 minus what gives me 0, it's going to have to be -2. Well, if I've got a -1 here, I'm going to have a -1 times 2. So you can write this mathematically if it helps you to think about it, that the +2 of the calcium minus the -1x is going to give me 0. Okay, so how many x's do I have to have? +2 minus what? -2. So I'd have to have 2 of those -1 charges. And this is just some examples that you'd have to have 2 lithiums for every 1 oxygen because the oxygen's a -2, and so on. So those are just some examples for you to look at. So how do we do this? How do we write this? Well, when we have a formula and we need to go backwards, we can do that. Or if we have the written name, we can write the formula. So if you want to write the formula for the compound, first you identify which element is the cation and which is the anion. And really what I do when I name them, the first thing I want to do is there a metal in it? If there's a metal in it, I know it's going to be an ionic compound. And so I'm going to name it like an ionic compound would be. So I'll use the group number to figure out what the charges are, because we're using these representative groups, 1A, 2A, 3A, and then 5A, 6A, and 7A. And then we're going to figure out how many of each type we need so that we have an overall charge of 0. If I have a +1 and a -1, that's easy because they already equal 0. If I have a +2 and a -2, that's also easy. They're going to be in a 1-to-1 ratio because they will have a 0. But if they have a different charge, so that the calcium is a +2 and the Chloride is a -1. I know I'm going to have 2 of these because they have to equal 0. So I'll have +2. I've only got 1 plus 1, so I'm going to need 2 of those in order to have a neutral atom with a +2 and a -1 times 2, and that equals 0. So if we look at these different examples, we use those subscripts to give us those overall numbers of the different elements or atoms that we need in each one of those formulas. Okay, so let's just kind of do one. Like, let's just say we have magnesium sulfide. All right, and we can look at our periodic table to figure out what those charges are. Okay, so magnesium is a +2. Sulfide is a -2 because it's in group 6A. So that's going to be the formula for that. If we're going to put sodium and sulfide together, sodium is a +1. Sulfide, we just said, is a -2. Okay, so how many sodiums are we going to need in order to cancel out all the negative charges? Well, we're going to have to multiply this by 2 so I can have a +2 and a -2. So that would give me Na2S. Okay, the more you practice these, the more they're going to make sense.